Hello students, welcome to the review lecture 11, in which we're going to talk about operations on functions. So basically we would like to discuss how to deal when we have two or more different functions, or maybe the same functions. So let's start with the definition, and we'll start by saying that we have two functions. Given functions f and g, we define f plus g, f minus g, f times g, and f divided by g as follows. And the first one we're going to define is f plus g of x. Well, before we do that, let's discuss this notation over here. A lot of people think that this is f plus g times x, but it's not really times x, it's f plus g evaluated at x. So it's not a multiplication. It's not a multiplication. All right, it's not a multiplication here. So how we're going to define it? We're going to define it as f of x plus g of x. Then we can define f minus g of x. So this we can define as f of x minus g of x. We can also define f times g of x by taking f of x and multiplying it by g of x. And the last one that we need is f divided by g evaluated at x. So we're going to take f of x and we're going to divide by g of x. And when we divide something, we don't want the denominator to be 0, so we have to say that g of x is not equal to 0. Before we finish this definition, it would be good to say what would be the domain of this function. So let's try to write it out. So we'll say that for the functions f plus g, f minus g, and f times g, the domain is defined to be the intersection of the domains of f and g. Right, so for the first three, it's easy to define. Now we would like to define the domain for the quotient of f and g. So we'll say that the domain of f divided by g is the intersection of the domains of f and g, but we have to exclude the points when g of x is equal to 0. So with the points where g of x is equal to 0 excluded from the domain. So that concludes this definition. So it's pretty straightforward definition, except we have to worry when we divide f by g. So let's do some examples for these functions. So the first example we're gonna do is the following. Let f of x to be equal to the square root of x plus 5 and g of x to be equal square root of x minus 3. So first of all, we would like to find the domain of f and g. So domain of f of x is equal to, let's try to figure it out. So we have to take x plus 5, set it equal to 0. This will tell us if we subtract 5 from both sides, we're going to get x is greater or equal than negative 5. So graphically we have negative 5 and everything to the right would work. Alright, so the domain will be bracket negative 5, positive infinity, parentheses. Then we would like to find the domain of g. So we're going to take x minus 3, we're going to set it greater or equal than 0. And if we add 3 to both sides, we're going to get x greater or equal than 3. So we have our real line. We have number 3 over here. And everything to the right of 3 would work. So conclusion, bracket 3, positive infinity, that's the domain of G. So we made the first step. Now let's try to combine these functions together. So first thing we're going to do, we're going to take f plus g evaluated at x. So it's going to be square root, we just use the rule first. So f of x plus g of x, so we have square root of x plus 5 plus the square root of x minus 3. That was the first one. The second part, we're going to do f minus g of x. So it's going to be f of x minus g of x. So we take a square root of x plus 5, we subtract the square root of x minus 3, and there's no real way to simplify it, so we'll just leave it like this. The third one would be f times g of x. So according to the rule, we have to take f of x, we have to multiply by g of x. So we're going to get square root of x plus 5 times the square root of x minus 3. Some people might want to write it as 1 square root like this. Not really helpful. Not much we can do for the simplification here. And the last part is what is f divided by g evaluated at x. It's going to be f of x divided by g of x. So we're going to get the square root of x plus 5 divided by the square root of x minus 3. And again, some people might want to write it as 1 square root, not really helpful, but that's what it is. The last thing we need to do is to find the domain for this function. And if you remember, the domain for first 3 functions is the intersection of the domains. So let's try to find it. So we have the domain of the first one starts at negative 5, goes all the way to infinity. And the domain for the second one starts at positive 3 and goes all the way to infinity. So we just need to find where the red curve intersects with the black curve. And this happens between 3 and infinity. You can clearly see it from the picture. So this would be the domain for this function. The domain for this function will be also 3 to infinity. And the domain for the product will also be from 3 to infinity. Now we need to talk about the domain for the f divided by g. It has to be also the domain, the intersection of 2 domains, so it will be from 3 to infinity, but when we take x equals 3 and we're going to plug it into the, better to put here, into the g function, g will be equal to 0. So that means we have to exclude 3 from consideration for the domain of the fraction, and so our domain will be 3 to infinity, but parentheses and parentheses. So that concludes this exercise. Let's move to the next one. In this example, we'd like to talk about the danger of this definition. The danger is hidden, so let's try to do this exercise. Let f of x be equal 3 times the square root of x and g of x equal 5 times the square root of x. So if we think about the domain of this function, everything from 0 to infinity would work here. And if we think about the domain of this function, everything from 0 to infinity would work here. Any number greater or equal than 0 would work. So the example asks us to find f times g of x and find its domain. All right, so let's do this out. So we have f times g of x. According to the definition, this is f of x times g of x, which is 3 times the square root of x times 5 times the square root of x. And if we combine the numbers together, we're going to get 15 square root of x squared. But what do we know about square root of x squared? That this is just x. All right, so we figure it out. And if we look at this function, we should say that the domain, look, 15x, anything would work for 15x. So we should say minus infinity to infinity, right? Now this seems like an easy exercise, but remember the word was danger. I did something wrong over here. Let's try to figure out what I did wrong. According to the definition, the domain of the product is the intersection of the domains. And the domain for the first function was from 0 to infinity. And the domain for the second function, for the g of x, was from 0 to infinity. So this is not really correct because I cannot plug in negative number into the f or g. Conclusion. The answer for the domain should be the intersection, so it should be from 0 to infinity bracket parentheses. All right, so we can't really look at this answer. We have to follow the definition for the domain. All right, so one small word about notation. So notation could be confusing in mathematics, but let's try to figure out what we're going to talk about. F of x times f of x. If we multiply two functions together, we have to get f of x squared. But most of the times people put this 2 over here. Right, so it should be written like this, but most of the time it is written like that. Another thing that we have to discuss, what is f cubed of x? F cubed of x, it's basically f squared of x times f of x, which means f of x times f of x times f of x. All right, so again, don't get confused by this cube. And last topic for the discussion over here is the composition of functions. So composition of functions. Very important topic. So I'll put an exclamation point here, maybe another exclamation point, and the third one here. So why it's so important, you will see later in the semester. It's kind of hard to talk right now about why it's going to be playing a big role, but this is a composition of functions. So let's try to figure it out. Let's start with the definition here and see what we can come up with. So given two functions f and g, the composition of f and g denoted by a little circle. So f little circle g is the function defined by f of g of x. So if I put everything onto one line, we have f composed with g evaluated at x is equal to f of g of x. That's what we mean by all of these words that were written above. The last thing to do is to define the domain, which is not that easy to do for the composition, but let's try. So where the domain of f composed with g consists of all values x in the domain of g for which g of x is in the domain, no technical issue, is in the domain of f, So what do we mean by this? If we take x that works for g, we can calculate g of x that should works for f. All right, so first we want to find all of the x's that work for g such that g of x works for f, because we want to calculate f of g of x. Not that easy to understand, but again, we can discuss it in class. So let's do an example for this idea. All right, so this example asks us to find f composed with g if f of x is equal to x squared plus 3 and g of x is equal to square root of x. All right, so let's start with the domain. So domain of f of x is, so let's look at f of x. For f of x, anything works. No matter what number you plug in, it will work. So it's minus infinity to infinity. Then for the domain of g of x, we dealt with square roots many times. So any non-negative number will work. So everything bigger or equal than 0 would work for this function. All right, so now we're going to the composition. So what is f composed with g of x? So I suggest to actually follow the definition and write it like this, and then take g of x and plug it in over here. So we're going to get f evaluated at the square root of x. So what does it mean to evaluate f at the square root of x? We have to take square root of x and plug it in for this x over here. So we have parenthesis square root of x squared. So again, we take square root of x and we write it instead of this x using parentheses. plus 3. So what do we get at the end? Square root of x squared is x. So we get x plus 3. All right. So let's try to see. So again, the domain of this function should come from the domain of g such that it works for f. But since everything works for f, any number in the domain of g would work for the composition. So that means the domain of the f composed with g is equal to 0 to infinity. Again, we take the whole domain of g. Even though it looks like we can plug in -5 here, but it's not really true. Because if we plug in -5 into g, it's not going to work. And we need to evaluate g first to get to here. All right, a little bit of a complicated idea, but I put 3 exclamation points for this composition of functions. All right, so let's do another example. So in this example, we're going to take f of x to be equal to x minus 1, and g of x, the same as before, is going to be square root of x. So the domain of, oh, I forgot to say what to find. Find g composed with f evaluated at x. All right, so first let's start with the domain of f of x. The domain of f of x, again, it's a straight line, so anything would work for it. So minus infinity to infinity. Domain of g of x is as before from 0 to infinity. So now we're ready to find the composition. So g composed with f evaluated at x. According to the definition, this is g of f of x. So we're going to take f and we're going to write over here. So it's going to be g, and we take x minus 1 and we write it over here. Then we have to take x minus 1 and we have to plug it in instead of x inside of the g function. So we're going to get square root of x minus 1. So what would be the domain of g composed with f? So basically, we need to take all of the values from the domain of f, but the domain of f was all real numbers, such that g would work, all right? So basically, we want to take everything where f would make sense for the square root. So that means f has to be greater or equal than 0. F of x has to be greater or equal than 0. Sorry, small mistake here. Should be greater or equal than 0. So we add 1 to both sides. We get x is greater or equal than 1. So the domain will be equal to everything from 1 to positive infinity. All right, so that's the operations on functions. We're going to use it all the time, so we'll practice with it a little bit more during the semester, but I'll see you in the next lecture.